Before we proceed to some examples of problems that will be solved using exponential generating functions, let's try to illustrate the equivalent sequence and generating functions in terms of exponential for the given illustrations here, or expressions. To start with, we have your e to the power of x minus 1. We are doing this so that when we have a problem later on and these identities will be used or may come out in the process, that we know what is its equivalent, or vice versa. We know that e to the x is actually the exponential generating functions for the sequence 1, 1, 1, 1, and so on and so forth. This is actually equal to the notation identified as the summation of your x to the power of r over r factorial. Let me rewrite this again. Summation, okay, as r starts from 0 to positive infinity, which would give us the expansion of 1 plus 1 x to the power of 1 over 1 factorial plus 1 x to the squared over 2 factorial plus that you reach a portion when you have here 1 x to the power of r over r factorial, and so on and so forth. Okay, but that is for e to the power of x. What is e to the power of x? Then minus 1. So to identify or to illustrate that, let's simply try to subtract 1 from the entire expression equivalent to this. Again, this is again expressed as 1 plus x to the power of 1, or x, simply x over 1 factorial. Let's not simplify the factorial notations in the meantime. You have here x cubed over 3 factorial plus that until you have here x to the power of r over r factorial. So with this now, to illustrate the equivalent exponential generated function at the same time its sequence later on. So we'll have something like this. Minus 1 would be equal to this expression 1, okay, plus x over 1 factorial plus x squared over 2 factorial plus until x to the power of r over r factorial plus so on and so forth, then minus 1. Okay, so simply subtract 1. In short here, obviously, there's only one thing that we could remove. Or let's try to remove the grouping symbol first. Okay, and you probably have an idea already on what will happen next, and probably the resulting generated function and sequence. Sorry for that. You have here plus and then minus 1. Definitely, 1 here will be removed. Okay, 1 minus 1. That's the only item to be removed. Hence, you will have here x over 1 factorial plus x squared over 2 factorial plus plus x to the power of r over r factorial. This is a generated function, or the exponential generating function for e to the power of x minus 1, which would give us a value in sequence, or the sequence would be, okay, 0. We start with 0 because we don't have here the first term. 0 and then 1, 1, 1, 1, and so on and so forth. Okay, what does this tell us now? Okay, that's the implication. What's the implication for this? If we're talking about selecting a certain object, okay, in a set, and it is counted in part of the arrangement, or etc., this means that the portion where not selected portion, it is the not selected portion, okay, since it's 0, it would mean that there is no chance that it's not selected. In short, if this is our given identity for a certain situation or an object, it automatically states that the least possible opportunity for it to be chosen is always chosen once. Okay, and then this is chosen, but this is chosen twice, this is chosen once. Okay, that would mean in this case that certain object in a set is always chosen, part of which it would not be there's no chance that it is not part of a certain arrangement. Okay, so let's have this for this specific illustration, and we'll have to illustrate as well similar situations like this as to its equivalent exponential generated function and what they call this one, and sequence of numbers, and definitely some of the implications if possible. Thank you very much for watching.